All right, welcome back. Today we're going to do further integral formulas. Now remember, every derivative rule is an integral rule by the fundamental theorem. And there are a couple we haven't used yet. So for instance, we had these rules for the inverse trig functions. D by dx of the inverse sine of x was 1 over the square root of 1 minus x squared, and d by dx of the arctangent was 1 over 1 plus x squared, and then finally d by dx of the inverse secant was 1 over the absolute value of x, the square root of x squared minus 1. Okay, and because we know how to differentiate them, then we know how to integrate them. So this will say that if we're looking for an antiderivative of this function, then the answer is the inverse sine plus c. And if we want to integrate this function, then the answer is it's the inverse tangent and finally, if we want to integrate this guy, it's just the inverse secant. All right, so really that's all there is. Let's do an example. So this is something that comes up a lot in Cal 2. You might be wanting to integrate something like this, 1 minus 4x squared dx. Okay. Well, we look at it and we notice it's very close to something we know how to integrate. If only that 4 wasn't there. So what we wish was happening, that instead of having 4x squared, we really had just u squared. Because if it was 1 minus u squared, that would be this example we did up here. Okay, so that gives you a really good idea of a substitution. So let's try u, take the square root of both sides, to be 2x. If I do that, then I get du is 2 dx. Okay, and if I do that substitution, then the integral of 1 over the square root of 1 minus 4x squared dx becomes, well, the dx is half of a du, so I get a half of a du. And then that 4x squared, well, that's just exactly u squared, so I get that. And that's exactly something we know how to integrate. It's the arc sine. So remember, that was the formula up here. So now we just need to change back into x language because we have u's there. So remember, over here u was 2x, so this is 1/2 the inverse sine of 2x plus c. And that's all there is. Okay? All right, there's one other class of things we had and haven't taken advantage of yet. So remember, we had this formula, d by dx of b to the x was the log of b times b to the x. And remember, we got that just by writing b to the x as e to the log b times x, and then using the chain rule. But whatever. Anyway, this was the rule. So you can divide both sides by this constant here. So that'll be b to the x all over the log of b. So this guy's derivative is just b to the x. Which means if you are looking for an antiderivative of b to the x, Well, you want to find someone whose derivative is that, and, well, that formula right above it tells us someone whose derivative is b to the x. It's b to the x all over the log of b, plus a constant. Okay? So, let's do an example of that. Let's do the integral from 3 to 5 of 7 to the x dx. Well, we know an antiderivative is just 7 to the x all over log 7. That's what we wrote right above. And then we evaluate this from 3 to 5. So we get 7 to the 5 minus 7 cubed all over log 7. And, well, if you put this on your calculator, it's fine to leave this as the answer because that is the answer. But if you want a number, it turns out a decimal, it turns out to be about 8460.8 if you put it on your calculator. Anyway, that's it for this section. Ciao.